Hello and welcome to our lesson on climate change. So in previous lessons we've looked at the idea that carbon dioxide, which is a greenhouse gas, the levels are increasing. And we looked at the idea that some of the reasons for this could be natural, like increased volcanic activity, or they could be anthropogenic, which is human activity due to deforestation or pollution, burning of fossil fuels. We also know that methane, which is another greenhouse gas, their levels are increasing as well. One of the natural reasons for that, again, would be volcanic activity. We can't control that. It does pump out a lot of methane into the atmosphere. And also the anthropogenic reasons, the human activities. One would be the overproduction of cows. Now, you've got to be careful with this one. Cows obviously are natural, but they do produce methane from digestive processes. And they release that into the atmosphere. However, because we are farming a lot of cows, that level is increasing. You would argue that that's a human thing because we are breeding more cows that maybe maybe natural. Sorry, I can't speak properly. There would maybe be natural. So that's why you put that under anthropogenic. Though there is an argument that maybe they're not producing as much as we like to think, or at least we previously thought. The other reason methane levels are increasing is the decomposition of things, of rubbish in landfill sites, and that does produce a lot of methane. You can see in that picture there's actually been a factory built, this might even be the one in Yorkshire, a factory built on that landfill site, and they actually use that methane gas, they trap it and they use it and burn it for fuel, but often that doesn't happen and that methane is released into the atmosphere. So I mentioned on a previous video that you're going to be given graphs for this. There's no way around it, and you just need to be really careful what you're reading here. So if I asked you how this graph shows evidence for anthropogenic activity causing the increase in carbon dioxide, what would you say? Well, you've got to remember anthropogenic is human activity. So where's the human activity? Well, it says global emissions here. Now, emissions is human activity. It's what we are putting up into the atmosphere as opposed to anything else. And we have some dates here. They're fine. Humans have been around in that time. And we can see here the carbon dioxide levels increasing. So what we could say here is the global emissions are increasing and decreasing at a similar pattern, in a similar trend to the carbon dioxide levels going up and down. Now, the reason it's like this is it's offset slightly, isn't it? Because you wouldn't expect there to be it to be instantaneous with increased the emissions, and therefore the carbon dioxide in the atmosphere is also increasing. But there's a bump there and there's a bump there. So you would agree that there seems to be a connection, a correlation between global emissions, which is humans, and carbon dioxide levels going up. Okay, so what about this graph here then? Would you argue that this is suggesting that humans are the cause of global warming, or are the cause of carbon dioxide going up, or the temperature increasing? So that's global warming. Or would you suggest that it's nothing to do with humans, or maybe evidence against anthropogenic activities causing the problem? Well, I think the big one here is recognising we've got the dark blue is the carbon dioxide levels and the temperature is the light blue. So there definitely seems to be a correlation between the temperature and the carbon dioxide levels. As the carbon dioxide levels tend to go up, the temperature goes up, and as the carbon dioxide levels go down, the temperature goes down. Now, it's not perfect. There are areas where the correlation breaks down. So here, I don't know if you can see this, if I do it here, this area here, the temperature's gone down much further than you would expect. Or this one here actually is probably slightly better. The temperature's gone down, but the carbon dioxide levels have gone up. So there does seem a good correlation there. But it is not perfect, so you could argue maybe that there is something else going on here. Now, the big reason I would argue that this is not to do with humans is the dates. Look at the dates. Okay, age before present. Okay, this is a long time ago. Some people would argue humans weren't even around at this time. Definitely, we didn't have industry. So we're not caught, we're not polluting the atmosphere in the same way we are doing today. So you've got to be really careful at looking at the question. What is it actually asking? Is it asking, is there a connection between carbon dioxide levels and temperature? I would argue absolutely yes, although it's not perfect. Is there evidence that humans are causing that problem? No, because you would argue that human activity isn't recorded on this graph. Humans are not around in these years. Okay, so looking at this one, okay, so again, what is this graph showing you? Is it, again, you'd have to look at the question. Is there a relationship between carbon dioxide levels and global temperature? Well, there does seem to be a correlation, doesn't there? As the carbon dioxide levels are increasing, the global temperature is increasing. So yes, there seems to be a relationship. Is it perfect? No, there's definitely the global temperature is going up and down a lot more than the carbon dioxide, which is relatively steady. So is there something going on that is not recorded on this graph? Absolutely. Evidence it's anthropogenic. So human, well, the dates are okay here. You could argue 1880, this is the start of the Industrial Revolution. It's definitely increasing a lot here. The technological age where we're using a lot more computers, that takes a lot of energy, a lot of pollution there. So you could argue that there's definitely a suggestion that human activity, industrialization and technology, it definitely seems to be having an influence on carbon dioxide. It's the right years, and that might be affecting global temperatures. Is it perfect? Absolutely not. This is a really good example. 1940s, global temperature goes up massively, whereas the carbon dioxide level actually drops slightly. What's happened there? Again, is it a volcanic eruption? Was there a spike in solar activity? We don't know. The graph doesn't show us that. So climate modelling, looking at climate change and looking at all the different things that can affect climate is massively complex. And you just need to be aware that, and be able to discuss whether your graphs match or show any kind of relationship between things. And of course, I mean, you can see here, I've deliberately picked very confusing looking ones. Data modelers, climate modelers take in all sorts of things. So they will look at not only human activity, carbon dioxide levels in the atmosphere, they will look at solar patterns, they will look at volcanic eruptions, they will take into account sea levels and cold winters, and how that would also affect the future. So if you look at this bottom right here, this was a model done by the Canadian Climate Model Survey, and you can see here the model predicted a massive increase of just about everything that they were looking at, and the reality was not half as bad. And that's simply, it just shows how difficult it is to predict what's going to happen next, because it is so complicated. And if we talk about investigations and we only change one thing so we know what's going on, well, this is a really good example of lots of things changing and therefore really not knowing how to predict the future as accurate as we'd like, because you've got so much to consider and to take into account. And that's why often when they say, oh, it's going to be even when they say it's going to be a sunny summer or warm summer, and you get there 6 months later and actually it's rubbish, it's difficult to predict the future when you're looking at climate modelling. So then we're looking then, we've established that some of it might be anthropogenic, it might be human activity. We're definitely not helping the situation. We could definitely do better. So then we look at then, okay, what can we control? How do we mitigate our effects? How do we reduce the effects that we can control? We can't control everything, but what can we do to reduce our effect on greenhouse gases and therefore global warming? Well, these pictures hopefully will help you. So alternative energy sources that don't use fossil fuels, so using wind power, that doesn't pollute, using solar power, it doesn't pollute. We've talked about recycling, so we're not using raw materials, but also we're not using as much energy. Using energy efficient light bulbs and things like that, energy efficient fuels. Things like insulating our houses. So if you don't have any insulation and you're heating up your house, you're losing a lot of that heat very, very quickly, which means your heating's got to stay on for longer or higher. Whereas if you insulate, your house warms up quicker, and therefore you're not going to have to use as much fuel. That's causing less pollution. Things like looking at where your food's coming from, less air miles, buying local, all those sort of things you can talk about are going to mitigate our effects on the environment and reduce the amount of carbon dioxide and other greenhouse gases we're adding to the atmosphere. Things like eating a vegetarian diet, or at least eating less meat in the week, may help towards producing. We're not breeding as many cows, and that may help with the methane problem. The jury's out on that one. So what are the government doing to help the situation? Well, they have kind of committed to doing better. They brought in the plastic bag charge a few years ago now. It's gone up since I wrote the 5p. It's getting people to reduce the amount of new plastic bags they are buying and using, so we're not making as more in the first place. That's going to be, if we're not making as many plastic bags, it's going to reduce pollution. So recycling is a massive part of reducing our environmental impact. And if you think you're not going to make any difference, it's it's just not true. If nobody does anything, we're going to be in trouble. If everybody does something, we're going to be in a better situation. And if some people do something, then that's better than nothing. Government also are committed to planting more trees, so it's what's called reforestation, because we know obviously plants and trees absorb the carbon dioxide through photosynthesis, so that's a way of reducing the amount of carbon dioxide in the atmosphere. So just, what are the government doing to help us? Okay, so if you'd like to pause the video and have a go at this question, is all one. I've just had to snip it so it fits onto the page a little bit better. Okay, so I'm going to read this question. Look at the graphs. They show the amount of carbon dioxide in the air and the temperature of the earth. Which one's which? So that's carbon dioxide and that's your temperature. Okay, so they've actually put them on two separate graphs rather than together. That's nice, thank you. And they've changed over the last 160,000 years. Right, that to me is important because 160,000 years ago, according to kind of popular science, we weren't around. So anything up here is not human activity. So we just need to be very careful here. Okay, so where would humans appear on this graph? Well, if that's present day, so kind of 2020, that's 20,000 years ago, 40,000 years ago. Yeah, human activity, especially human industrialization, is kind of this bottom bit, isn't it, here, this very last little bit, which is interesting because you're actually seeing this jump here, aren't you? That jump there, which actually then isn't showing the temperature. The temperature actually goes down. That's very interesting. Right, can you see what I'm doing? I'm kind of looking and thinking, what are these relationships? Let's look at the question. So it says other gases can contribute to global warming. Look at the table. So other gases, remember we mentioned greenhouse gases, so methane and nitrous oxide and water vapor. Okay, so look at the table. It shows how long each gas remains in the air. So its lifetime, its global warming potential, so how much it will cause global warming, and the current level of each gas in the air. Okay, so carbon dioxide doesn't stay very long in the atmosphere. It's got a relatively low, oh, that's interesting, a very low chance of causing global warming, or it will do, but not as much as the others, but there's a lot of it. Whereas nitrous oxide lasts a long time, causes a massive amount of global warming, but there's not a lot of it in the atmosphere. Okay, so it says evaluate, okay, the likely contribution of each gas to global warming. So there's 3 marks here. So if I talk about each gas and I'm looking at, okay, are they contributing or are they likely to be contributing to global warming, I'm going to get those 3 marks. So what do the mark schemes say? Here you go. So comment about which gas causes the greatest or the least amount of global warming with an explanation. Reference to 2 of the following factors about carbon dioxide, so the least global warming potential and the shortest lifetime but the highest current level. and then talking about the methane and the nitrous oxide as well. So realistically, if you talk through each of those, you'd have got the 3 marks. Okay, that's it for this lesson, guys. I'll see you later.